Solutions to the Quarter 3 exam study guide, starting with number 1A. How quickly is the car accelerating? We're going to use the acceleration equation equals the velocity squared divided by the radius. Velocity is given to us as 50 meters per second divided by the radius. They give us the diameter, half of which is going to be the radius. And when we solve this, we get 25 meters per second squared. Number 2 is asking to determine the centripetal force, and so we're going to use the same acceleration in the last problem. Centripetal force equals mass times acceleration. The mass is 800 kilograms. The acceleration we solved for in part 1 is 25 meters per second squared, and when you multiply these, you get 20,000 newtons of force. And realize that the friction, or frictional force, provides the centripetal force. So essentially, the centripetal force is equal to the frictional force. Part 3, what is the minimum coefficient of friction? Coefficient of friction is the force of friction divided by the normal force. The force of friction is actually going to be the same as our centripetal force, and the normal will be our mass times gravity. And so coefficient of friction equals 20,000 newtons divided by our mass, 800 kilograms, times acceleration due to gravity, 9.8 meters per second squared. This gives us a coefficient of 2.5. Number 2, part A, determine the beetle speed on the turntable. And we're going to use the 45 revolutions per minute and the 10 centimeters, which is our radius, to figure this out. We're going to put 45 revolutions per 1 minute. We're going to start by bringing down revolutions, and for every 1 revolution, it's 2 pi times r. We're going to change r to meters, so that's going to be 0.1 meters. This is going to cancel revolutions and give us meters at the top. We're going to bring up minutes and go to 60 seconds. So we'll cancel minute, and this is equal to 0.47 meters per second, and that is our velocity. Part B, we're going to use the velocity from part A, and we want to determine the acceleration. So we're going to use acceleration equals velocity squared over r. The velocity in the last problem was 0.47 meters per second. Square that, divided by the radius, 0.1 meters. You're going to get an answer that conflicts with your study guide, and so the correct answer should be 2.2 meters per second squared. Part C is asking how much centripetal force, and the centripetal force is equal to mass times the acceleration. So we'll use the mass given in the problem, 0.0001 kilograms, times the acceleration from part B, 2.2 meters per second squared, and this will give us 2.2 times 10 to the negative 4 newtons. Number 3, we want to determine how quickly is the airplane accelerating, and so we will use acceleration equals velocity squared over the radius. This is our velocity, this is our radius, and so we will plug it in. 7 meters per second squared divided by 5 gets us 9.8 meters per second squared. Part B, to determine the tension. You're given a tension of 2.45 newtons, and we want to determine the mass of the plane. So we're going to use centripetal force is equal to mass times acceleration. We're going to use the acceleration we found in part 1. And so to solve for mass, we will divide both sides by acceleration. So mass equals the centripetal force divided by the acceleration. And so we'll do this over here. Mass equals 2.45 newtons divided by 9.8 meters per second squared gets us 0.25 kilograms. Number 4, we want to determine the force needed to pull the leash. And so we're going to use centripetal force equals mass times velocity squared divided by the radius. We're going to use 30 as our mass, 10 meters per second is our velocity, divided by, and 3 meters is our radius. So the centripetal force is equal to 1,000 newtons. Number 5, for part A, we want to determine how fast is he moving. So our original equation is centripetal force equals mass times velocity squared over the radius. We want to solve for velocity squared. So we're going to actually rearrange this equation. We'll multiply both sides times r. That cancels our r. Now I will divide both sides by mass, which will cancel mass. And now I'll take the square root of both sides of the equation. This will leave me with velocity equals the square root of the radius times the centripetal force divided by the mass. The radius given to us is 1.5 meters. So velocity equals the square root of 1.5 meters times the force given to us is 260 newtons divided by, and the mass given is 65 kilograms. So the velocity equals 2.4 meters per second. Part B, we're going to have to use, they're trying to determine how much to make one complete revolution. Remember that circumference is equal to 2 pi r, which is equal to 1 revolution. So we will simply do 2 times pi times the radius, 1.5 meters, given here, and that's equal to 9.42, and that's our entire distance to make one complete revolution. Then we'll use velocity is equal to distance divided by time, and this is equal to our distance. We're going to use the velocity that we found in part A, 2.4 meters per second. So I'm going to solve this now for time. I'm going to multiply both sides by time. That makes time cancel. And now I'm going to divide both sides by velocity, which leaves me with t equals d divided by v. And so the distance is 9.42 meters divided by 2.4 meters per second, and that's going to equal 3.9 seconds. Number 6, this is going to start out using pendulums. So the period is equal to 2 times pi times the square root of length divided by gravity. And they want us to solve for the length. And so I'm going to go ahead and rearrange this equation to solve for length. I'm going to start by dividing both sides by 2 pi, which causes 2 pi to cancel. Then I'm going to square both sides in order to get the square root off the right side. So squaring a square root basically cancels a square root. And now I can multiply both sides times gravity, and this will cancel out the gravity, leaving me with length equals. so length is going to equal, and we have gravity, so length equals 9.8 meters per second squared times the period is given to us as 12 seconds, so 12 seconds divided by 2 pi, and we'll square this value. And so when we solve this in our calculator, we get a length is equal to 36 meters. Number 7, again, we'll use period equals 2 pi times the square root of length over gravity. And again, we're trying to determine the length of the pendulum. So once again, I will divide both sides by 2 pi, which cancels 2 pi. I will square both sides, put our equal sign here, which cancels out the square root. And then I will multiply both sides by gravity, which cancels gravity, leaving me with just length. So the length is going to equal the gravity, 9.8 meters per second squared, times the period is 1.0 seconds divided by 2 pi, and we will square that value. And so my length for number 7 equals 0.25 meters, and your study guide is expressing it as centimeters, so 25 centimeters. Number 8, we're going to use the period equals 2 pi square root of length divided by gravity for all 3 of these. So for part A, period equals 2 pi square root of 3.500 divided by 9.832, which equals 3.749 seconds. To get frequency, you take 1 over the period, which is going to end up giving us 0.27 hertz. Part B, period equals 2 pi square root of 3.500 over 9.803. This is from the second part. And that's going to give us a period of 3.754 seconds. Again, frequency is 1 over 3.754, which gives us 2.2664 hertz. And for part 1, the extended answer is 0.2667 hertz, because these answers are all going to be very similar. So we'll keep 4 sig figs. And then letter C, T equals 2 pi square root of 3.500 over 9.792, and that gets you 3.756 seconds. Frequency will equal 1 over 3.756 seconds, and that's 0.2662 hertz. Okay, the final calculations will be found on part 2 on YouTube.